This video is to review how to factor the trial and error form of trinomials. Basically, it's when your a value in a quadratic equation is not a 1, it's another number other than 1, 2, 3, 4, so forth and so on. So let's go over a really good method on how to do this, and it really is quite easy. So we're going to take a look at example 4 here. And again, this is a review, so the numbering may be out of order because it's something that I'm sure you've done already in class. It's just a little extra. All right, I definitely know it's what's called trial and error because of the 2 in front, which means my a value is not a 1. And so it's not an easy factoring with 2 binomials. It's a little bit more difficult because of that 2 there. So the best way to do this is to take your first term, which is the 2, and your last term, which is a -3, and multiply them over to the side, which would give me a -6. I now want to find factors of a -6 that would give me the term in the middle of this trinomial. So what times what would give me a -6, but when added would give me a -5. And you're correct, it would be a -6 and a +1. So now I'm going to rewrite that trinomial so that instead of having a -5x in the middle, I'm going to have a -6x plus a 1x, which would give me that -5x. So now I have 2x squared minus 6x plus 1x minus 3. So basically what I did is I rewrote the middle term. If you look at what I have now, I have what's called 4 terms, and the only way to solve to factor 4 terms is to do what's called grouping. So basically, we're trying to get trial and error to be a grouping factoring, because it's a lot easier to factor grouping. So I'm going to group the first 2 terms and the last 2 terms. I'm going to GCF each binomial. All right, in the first 2 terms, I can GCF a 2 and an x and get x minus 3. The last 2 terms, the only thing I can GCF is a +1 and get x minus 3. Now, to know you did grouping correctly, you should have a factor that is the same for both sets. And we do, it's x minus 3. So what you do now is you bring down the GCFs and put them together as one binomial and bring down only one of those common factors. And you're done. There's trial and error. There's the factoring of that trinomial to 2 binomials. We don't have to do the t-bar because it didn't ask you to solve. We're just basically factoring. All right, let's try the next one, number 5. Again, I know it's trial and error because of the 3, which means my a value in the quadratic equation is not a 1. So I'm going to change it to grouping. I'm going to take the first term and the last term, and I'm going to multiply them together and get a +6 this term. I need factors of a +6. That will give me a -7. So basically, it would have to be -6 and -1. I'm going to rewrite that trinomial to be 3x squared minus 6x minus 1x plus 2. Now I have 4 terms because, again, all I did was rewrote the middle term a different way. I'm going to group the first 2 and I'm going to group the last 2. And I'm going to GCF a 3 and an x out of the first pair and get x minus 2. I'm going to GCF a -1. Chances are, if your second binomial starts with a negative, you are GCFing out a negative so that you get a common factor. And you're going to get x minus 2. Ooh, wow, that helped. So I'm going to put my GCFs together and get 3x minus 1 and bring down one common factor, x minus 2. And there's my factoring of that trinomial. Now, a lot of people ask me, what happens if I put them in the opposite order you did? All right, well, let's try that. So let's say that instead of you writing it as 3x squared minus 6x minus 1x plus 2, you wrote it as 3x squared minus 1x minus 6x plus 2. Would you get the same end result? Well, let's see. Let's group. And the first pair, I'm going to GCF out an x and get 3x minus 1. In the second pair, I'm going to GCF out a negative 2 and get 3x minus 1. I put my GCFs together and get x minus 2 and bring down one common factor. I get the exact same two binomials as I did before, they're just in opposite order. And that's okay because multiplication is commutative. All right, let's do one more. All right, we have a nice one here. It's 4x squared plus 11x minus 20. Now again, it is definitely trial and error because of the 4. So I want to change the trial and error to grouping. So I'm going to take the first term and the last term and I'm going to multiply them over to the side. So I get a negative 80. Now I need factors of a negative 80. That would give me 11. I'm trying to think. Let's see. If I go down 8 and 10, no. Oh, what about positive 16 and a negative 5? That'll add and give me a positive 11, and that'll multiply and give me, oh, there it is. Okay, so let's rewrite it. Here we go. So, and again, if you don't get it as quick as I do, you write down all your possibilities. You know, at 80, so you know 10 can go into it, you know 5 can go into it, so eventually you would have gotten it. So now we have 4x squared plus 16x minus 5x minus 20. So again, I just rewrote it to have 4 terms, and I'm making sure that 16x minus 5x gives me the middle term of 11x, and it does. Okay, so now I'm going to group. On the first two terms, I'm going to GCF out of 4 and an x and get x plus 4. In the second pair, it's starting with a negative, so I'm going to pull out a negative. I'm going to pull out a negative 5 and get x plus 4. I got a common factor. Put the GCFs together. Bring down one common factor. Now I'm going to double check. Can any of those binomials be factored even more? Because sometimes they may be able to. And in this case, no. I'm set, so there's my answer. I hope this helped you a lot with when you're factoring a trinomial that has a leading coefficient greater than 1. Again, please take your time and review the video as many times as you need to.